In this video, kind of goes through what we do when a customer has a battery backup system that we service. Our company started by installing these systems. This is actually one that we installed ourselves. Um, and here I am pulling out one battery at a time. Yep, there's 24 of them and they are 75 pounds a piece. So no, I didn't have to go to the gym that day. Even though I did have help from my buddy Mike. Um, so we pull one out and put new ones in, one at a time. This was in a homeowner's basement. Um, so access to the outside was pretty far. But fortunately, we had a couple dollies, so we dollied them out. We didn't have to hand carry them through the basement. Right here is the battery temperature sensor. The temperature sensors are connected to the inverters to tell the inverter charger to slow down or speed up depending on the temperature of the battery. Those are the new ones there. These are the old ones on the right side. It's a good shoulder workout. Those are 4-aught stranded cable, welding cable, basically, the orange cables there. And those are how they get paired parallel to each other. It sounds, or sorry, it looks like I'm doing this very easy. It's because I've done thousands of these so far. But if you're not comfortable working with DC voltage, do not try this. Do not attempt to do this yourself. It is very dangerous and you can easily get hurt. So don't try doing this unless you're familiar with what you're doing and DC voltage. Each battery is 100 amps. There's 4 of them in a series, still 100 amps at 48 volts. As you can see, you need a pretty heavy duty truck here. Everything is very manual, very labor intensive. Yeah, this was real fun stacking these all together. We were probably a little bit overloaded on the weight capacity of the truck. But it's all right. We didn't have far to go, so it was all right. Strap them all together so that they don't fly as we're driving down the road, fall off the pallet. And yeah. So here I'm just doing the final connections to all the terminals. Again, I can't stress enough. Don't try doing this if you're not familiar with battery voltage. Battery voltage is nowhere near the same as regular house voltage. It's completely different. Coming up in a little bit here, I'll talk about how this system is set up. If something's missing, post a comment and I'll do my best to answer any questions you might have.
So we just replaced these batteries. There's 24 lead acid batteries. They're about 105 amp hours a piece. So we have 24 kilowatt hours of battery power here. Actually, it's a little bit more than that. I think it's 30 kilowatt hours of battery power. This is a hybrid system. The homeowner has a Generac 8 kW fully automatic standby generator hooked up to a propane tank. This module is what you need if you have a old school 2005, 2004, 6, somewhere in that area, Xantrex SW plus 5548. And what that means is 5,500 watts at 48 volts DC. So these are 12 volt batteries. There's 4 in each module. They're paired in a series and then parallel to the inverter system. That's a lot. And then these two are talking to each other. This one controls that, which that talks to the generator. So when the batteries drop to a predetermined level that we can set, the unit, the generator, I'm sorry, the inverter will turn on the generator, which is pretty cool. And the way to do that is your low battery cutout. So we're gonna raise this to 47-ish, 46 and a half, somewhere in there. So this way the generator has enough time to charge up the batteries, and then it will turn itself off when the batteries get fully charged to 52, 54 volts DC. I'm just checking the settings here to make sure they're all in sync with the batteries that we have installed. So I'm turning down the charging amps from the generator. It's so that you don't tax the generator too hard, because that is only an 8 kW. So what these lights mean, that's the inverter status light. That should either be solid or blinking. When you have AC power, it will blink. When you're just running on batteries, that will be solid. AC2 is the generator. AC1 is utility power. That's bulk charge. That is float charge. Bulk is yellow, float is green. Red error light and a yellow status light. The status light should not be lit, but I have it running. I have this unit controlling the generator right now in manual, so I signaled the generator to turn on manually, as you can see here. So now I'm going to turn it off, and you'll see the status light go out, and all these other lights will go out. That's blinking because the generator is still running outside in its cool down mode. If that red error light is ever on, that's bad. So the unit will need attention. At this generator, so the reason why the AC2 light went solid is because the generator was in cool down mode, and when it's in cool down mode, it's still producing power, so the inverter doesn't know that, so it latched back onto the generator power. Unfortunately, that is a bad thing, but there's not much we can do about that, because it's primitive, it doesn't have the ability to control every detail of the generator. So we're doing a full test here. The bottom inverter is signaling the generator to start. So we'll see a yellow light here and then a green light. See? This is all very normal. Otherwise you'd hear me say, oh shit. So that's normal. During a power outage with the generator running, whether you have a portable or this is what you would see with a portable, and that's what you would see with a automatic generator. But that's what you'll see with a portable. 3 lights lit, 1 blinking slowly. Yeah, so this is a Xantrex inverter system, hybrid with a 8 kW Generac propane automatic standby generator. Xantrex was sold back in the late 2009, 2010 to Schneider Electric. These inverters are no longer manufactured. Not sure why. Probably because they worked too well. These were replaced by XW 6048s, which still is a 48 volt, but grid tie those inverters for renewable backup and renewable power. Unfortunately, governments haven't caught up to battery backup until now, but yeah, it's all working well. So now That's blinking because the battery voltage has gone higher than the settings that we have put in here. But during a normal outage, the generator would continue to run. This is just for testing purposes. So we have utility power back. The unit has locked onto utility power, but the generator is still running because it's in cool down mode. That's why AC2 is blinking and AC1 is solid. So you can also see that here as well. And it should turn off in 2 minutes. That's the cool down period for the generator. And that's it. The generator turned off. That blue light there will always be lit. That means it's operational. Pretty self-explanatory. If you have one of these, don't mess with these switches. It's unnecessary to touch them. Just leave them alone. Anyway, hope this helps anybody who has these primitive inverter systems, but they worked. Thanks.